Now we'll see an example of graphing a trig function. So we'll graph the equation y equals 2 sine of pi over 2x plus pi over 4 plus 3 outside. So again, in our form, this was a sine of bx plus c plus d. So our a is 2, b is pi over 2, c is 5 pi over 4, and d is 3. So we'll go through the exact same steps we talked about in the process. The first step is always to find the period. Now, since our trig function is sine, we use the formula 2 pi over the absolute value of b. So for us, that period will be 2 pi divided by, b is already positive, so the absolute value doesn't change anything, and the period is 2 pi divided by pi over 2. So we're dividing by a fraction. That's 2 pi times 2 over pi. Change your division into multiplying by the reciprocal of the denominator. Now those pi's cancel, and our period equals 4. So we'll remember that for later. The next thing to do is find the distance between our 5 special points on the graph. The period was the distance before the graph starts repeating itself. Each special point will be separated by period over 4. So that, in our case, is 4 divided by 4, which is just 1. So each of our special points is separated by a distance of 1 unit. Now, our formula for the phase shift is negative c divided by b. That does not matter on which trig graph we did, so it's always going to be negative c over b, which in our case, we have negative 5 pi over 4 divided by pi over 2. And again, change the division into multiplying by the reciprocal. We get negative 5 pi over 4 times 2 over pi. The pi's cancel, the 4 and that 2 cancel, and we're left with negative 5 halves. All right, the point of the phase shift, which is where the graph, the first special point of the graph, moves to. So our next step is to find all of our x-coordinates. And we have the x-coordinate of point number 1 is just the phase shift. And so that we just determined was negative 5 halves. Special point number 2 is point number 1 plus the period over 4. So in our case, we get the special point number 1 was negative 5 halves plus the period over 4 was 1. So negative 5 halves plus 1, we wind up getting negative 3 halves. Point number 3 is just point number 2 plus the period over 4. And so that would be negative 3 halves plus 1 is negative 1 half. And then point number 4 is going to be that point number 3, which was negative 1 half, plus 1, which is, now we've got positive 1 half. And finally, point number 5 will be that positive 1 half we just found, plus 1, and so that gives us an x-coordinate of 3 halves. Now we graph the function that we have so far. So in order to do this, it's a good idea to always graph our base function. So our base function was sine of x. And we know that we just draw a quick graph. It doesn't matter very carefully because we're only doing this to see what it looks like. Sine starts on the origin, and then it goes up, and then it goes back to the axis, and then it goes below the axis, and then we go back onto the x-axis. So our graph of sine looks like that. And this is our first point, our second point, our third point, our fourth point, and our fifth special point. So now we look at our x-coordinates of points 1 through 5, which is negative 5 halves, negative 3 halves, 1 half, and 3 half. So each of these tick marks will have to be a distance of 1 half. All right, you could zoom in more if you wanted and make each tick mark 1/4, so you'd have a slightly bigger graph. But for now, let's just make each distance 1 half. So let's label a few of these points, a few of these tick marks. So that means if this is -1/2, then this would be -1, -2. And in the positive direction, we'd have 1, 2, 3. None of our special points were going to be on any of these. We started out with -5/2. Sine, the first point is on the x-axis, so at -5/2, 1, 2, 3, 4, 5, we count over, and we have an x of first special point on the x-axis there at -5/2. And then let's just draw our graph, make that y-coordinate of 1, and so then this would be a y-coordinate of -1 down there. The next special point will be at 3/2, and we put a dot up there. That will be special point number 2. Special point number 3 will be at -1/2, and it goes back to the x-axis as we see there. Special point number 4 will be at -1 with an x-coordinate of 1/2. Special point number 5 is an x-coordinate of 3/2, and it goes back onto the x-axis. In order to graph, we just draw the graph that bounces up and down between all these special points. But we know our graph starts repeating itself after point number 5, so then the next point would be point number 2 extended over to here. And so then we have a point up at +1. Our next point would be on the x-axis, and our next point would be down at -1, and then we'd bounce back up to the x-axis and up to +1. So we could keep drawing our graph forever in both the right and the left directions. So we'll draw a little bit farther both ways. All right, but the graph never stops. It keeps going on forever and ever. However, all we've done right now is our x transformations, so we need to do our vertical transformations as well. So if we look, our vertical transformations, A was 2, and that means vertical stretch by 2. So anything that was up at +1 will now become +2. And if you didn't have a graph given to you, you could just cross out that 1 and say, all right, now that's +2. Cross out that -1 and say, all right, that's -2. However, we also need to do vertical shifting, and D was equal to 3. So we shift up 3. All right, so I'll need to change my coordinates a little bit because I have to go all the way up to 5. If it started out at 2, we move it up to 3. We'll need to go up to 5. This -2 will also go up 3. And so this will go to -1. So now we've got a nice new graph. We had special points at -1/2, -3/2, -5/2, +1/2, and +3/2. And we'll just this time make our y scale just go up by 1 each tick mark. And let's label a few of these x tick marks. All right, so the first special point of sine, if we regraph it, we start on the x-axis, and then we go up, and then down, and back up. Looks like this. So our first special point used to be on the x-axis, but now it's going to move up 3, so it'll be right there. And then our next special point used to be at +2, but it moves up 3, and so it'll be at 5. And then we go back to a middle point, and then we go back to +1, and then we go up to +3. And again, we can just keep repeating forever and ever in both directions, like so. And in the going left, we get points going down first, and then we bounce up to the middle, and then we have points going up and then down. And so our graph just bounces up and down between +5 and +1 forever and ever in each direction. So our special points move to there was our first point, there was our second, third, fourth point, and fifth point. Again, you don't need to label your points when you're doing your graph, but I labeled them here for you so you could see how our graph changed from this original graph 1 through 5 is now with all of our transformations here. All right, thank you for watching this example. In the next video, you can see an example where we take an equation and we take a graph and find the equation from that graph.